Good morning to all of you. Myself, Professor Yanvi Atpe from SNT College of Engineering and Research Center, Yeola, working as a assistant professor in electrical engineering department. So in a previous lecture, we started the new topic, that is displacement measurement. In that previous lecture, we studied already seen the uh, LVDT, construction working principle and advantages, disadvantages of LVDT. Now, in that lecture, we will see the RVDT. It is an electromagnetic transducer. What is RVDT? It is a rotary variable differential transformer. Only difference is in LVDT, we will measure the we can measure the displacement, that is linear displacement, and in RVDT we can measure the rotational displacement or angular displacement. In what is RVDT? It is an electromechanical inductive transducer that converts angular displacement into the corresponding electrical signal. It is the most widely used inductive sensor due to its high accuracy level. The coil of RVDT is designed to measure an angular position, so it is also known as angular position sensor. It is also known as angular position sensor. Unlike LVDT, RVDT is also a passive differential transducer. So the RVDT construction. The construction of RVDT is similar to the LVDT, but the difference is only is the shape of the core. Shape of the core. In LVDT, the shape of the core is soft iron core, but in the RVDT, the cam-shaped core or rotating core for measuring the angular displacement. The rotating core or cam-shaped core is used for measuring the angular displacement. It is the only difference in the construction of LVDT and RVDT. The RVDT theory, it is no, it would not denote the secondary voltages as the ES1 and ES2 shown in figure below, and also the sensitivity of RVDT is G. Having sensitivity is G. Then the angular displacement of the shaft will vary as theta is equal to G into ES1 minus ES2 upon ES1 plus ES2. The secondary voltage is determined the by the help of the equation given below as ES2 is equal to ES1 plus minus G into ES1 plus minus G into theta. The differential output ES1 minus ES2 will be determined as delta ES is equal to 2 into G theta. 2 into G theta. Also, the sum of the voltages will be calculated as the sum C, calculated as a constant C. C is equal to summation of ES is equal to 2 into ES 0. 2 into ES 0. The working principle of LVDT and RVDT both are same, but that is when the supply is given to the primary winding, according to the mutual induction principle, the EMF is into the flux produced by the primary winding, which will be linked to the secondary winding, and according to the mutual induction principle, the EMF induced in the secondary winding. And as the secondary winding having two separate windings, then the EMF induced in both the windings are different, that is ES1 and ES2. respectively. Hence, the net output voltage will be the difference between the induced or secondary voltage, that is E0 is equal to ES1 minus ES2. Then the concept, then how to measure the displacement, that is angular displacement is how to measure this angular displacement, that is it is either clockwise or either anti-clockwise with the help of following conditions. When the core is at null position, that is in that position, then the EMF induced in the secondary winding, S1 and S2, both are same. Both are same, and the output voltage is 0. And output voltage is 0. Means the flux linkage with the both the winding, and according to that the EMF is same, and the output voltage is 0. Means the the angular displacement of the core is 0. In case 2, when the core rotates in clockwise direction, when the core rotates in the clockwise direction, then in this case the flux linkage with S1 will be more as compared to S2. When the core rotate in clockwise direction, then the flux link to the S1 is greater than S2, and hence the EMF induced in the S1 winding is greater than S2 winding, that is ES1 is greater than ES2, and the net output voltage, that is E0 is equal to ES1 minus ES2, it will be positive. That means that the output voltage E0 will be in phase with the primary voltage, and means if the voltage output voltage is positive, that means that the the core rotates in the clockwise direction. Third case, when the core rotates in anti-clockwise direction, then in this case, the flux linkages with S2 winding will be more as compared to S1. That means that the EMF induced in the S2 winding, it is greater than the EMF induced in the S1 winding. Hence, ES1 is less than ES2. Means the output voltage, that is ES1 minus ES2, will be negative. Means when it means that the output voltage is negative, means it will be 180 degree out of phase with the primary voltage. 180 degree out of phase with the primary voltage. It means that when the output voltage is negative, you can say that the core rotates in the anti-clockwise direction. The advantages of RVDT is high accuracy, compact and strong construction. The consistency of RVDT is high, long lifespan, very high resolution, low cost, high durability, linearity is excellent. The performance is repeatable, easy to handle. The disadvantages is that the output of RVDT is linear, so it restricts its usability. The contact among the measuring exteriors as well as the nozzle is not possible for all time. The application of RVDT is actuator for controlling flight as well as engine, fuel valve as well as hydraulics, brake with the cable system, modern machine tools, nose wheel steering system, weapon and torpedo system, engine fuel control system, aircraft and avionics, engine blade air system, and robotics. This is your advantages, disadvantages, and applications of RVDT. So stop here.